Hi everyone, welcome to another part of our data analytics technique series. Today we'll be talking about data cleaning and data readiness method as a data analyst. If you've not watched the previous video, kindly encourage you to go back to check on them because this video is building up on one another. So today we'll be telling you what are the things to look out for when you are cleaning your data. So first of all, before you make any adjustments or you make any corrections to your data, make sure you have the original copy of your data. So create like a duplicate where you've not made any adjustments, just in case you make any correction and you want to go back to make those changes. So I would advise you kind of keep the original copy. So being able to identify what a data looks like, good data looks like is a skill. So you would get better at it the more you clean data, the more you work with data analysis projects. But in this video, we'll be talking about some of the things to look out for you to know if your data is ready for analysis. And you need the data to be clean. You need the data to be ready for analysis before you can go ahead to do your analysis. In fact, that is the first mindset you should have before you go ahead into doing analysis. Think about, I need to clean this data. However, there are some data who comes that are already cleaned, either by the person who give you the data, or most likely you just have minor cleaning. However, there are some data that might not need much of cleaning, but just need you to transform or to make some manipulation with the data. So that might also be called data cleaning in this sense. So always give room for data cleaning for data analysis. The consistency of data with the codebook description. So this is something that you need to look at. So if you're giving a code book, you need to be able to see if the code book that you are giving the content of the code book is consistent with the content of the data. So if you watch the previous video, a code book is a data that describes the data, or is a data that tells you what is in the content of the data. So if the code book tells you that marital status is in the data and you do not find marital status, or you do not find income, and the code book says there's supposed to be income, or there's a particular data that is in the code book that's not, there's a data that is in the, there's a particular column that's in the real data, but it's not in the code book. So basically inconsistency with the code book and the data. So those are ways to find out that, okay, there's something wrong. Either the data you have is incomplete and things like that. So one of the things you should look out for is proper labeling. And one of the things you can do is when you are creating a data for yourself, if you collect the data, try to ensure you use a proper label so that even though someone who doesn't understand like or doesn't have a code book, we have an idea of what the data is. One of the things we try to do when we are labeling a column or a variable is we try to avoid the use of space. So let me use something like marital status. So when you want to write that, you don't want to use marital space status. You want to use something like marital underscore status. So that's like a conventional way for naming a data. The reason why you want to do that is because some programming language or some software used for your analysis would read those naming as errors. And that's why the better convention is instead of just even writing marital status in full, which might be very long, you can write something like mass at. So that is like MAR underscore stat. Um, and that thing also is that if your result looks funky or irrational, so look at it again carefully. So let's assume you've done your analysis and your analysis results like doesn't make sense, or it's not coming out as expected as you want, or you do like a graph by gender and you find male, female, and you find something like maybe something else. So that makes you think, oh, there's something wrong. Then let me go back to clean this. So it's computer works with giggle, garbage in, garbage out. That's why you want to be careful when you see your results. But if you look at your data critically and you've cleaned it and your results is still not bringing what you think, then probably there might be other issues, either with the sample not being representative or not, or either that is just what the results saying. Moving forward, so these are like some data analytics techniques that you could, data cleaning techniques that you could also employ. So they include running some preliminary analysis. So what does running preliminary analysis mean? So this also include like running basic statistics. So for example, you have a project that you have to run a whole lot of bar charts, pie charts. You have to do a lot of things. You have to combine two, three variables to create a graph or do some regression and things like that. So before you go ahead to start to do those analysis, one of the things we do basic as a data expert is to run some basic statistics, something like mean, median, mode. So try to check, right, run those basic things first of all. So when you run those basic things, then this tells you, okay, since these basic things can work, then means that this data is okay. So in subsequent videos, we'll be telling you the kind of statistics or the kind of analysis to run for different kind of variables that you have, as if you have a numerical or categorical variable. But we won't talk about that in today's video. So another thing is to look out for weird results. Um, one other thing that happens more often than not is also human error or misinterpretation. So this is like one of the biggest problem where uh you are seeing something else, but the data is actually the one correct. And that's why as data analysts, you kind of work in groups or in teams in an ideal organization. If there's a error, what you can do if you are working alone is to go back to your analysis and try to check your how you did things and see if they were consistent. So try to avoid human error. Just try to or minimize. I think that would be the word. Just try to be more careful and try not to misinterpret. Sometimes you do the right analysis and you are mixing up things together, either male for female or single for married and things like that. So also, your cleaning might just need you to rename some variables. That's like the column or change some things. Also, some of the cleaning might be the fact that you have empty or null values. So in some data, empty or null values might mean different things. Um so empty means there's nothing there, like there's a space. So null values could also mean like there's nothing there, but they replace them with a placeholder. So let's say somebody says, if it's a null value, let us add 99999. So if somebody gives us their income from, let's say, 100,000 to 500,000, but if somebody doesn't give us their income, let us add 9999. So that's like a number. So your code book is going to tell you that most times null values are replaced with nine or something or zero. So they use zero zero. So but most time people use nine nine. They use nine in multiple places. So you probably almost treat them the same way as empty and null values. So that's also things that comes with data cleaning. However, it's not all the time where you have empty places or null values that you kind of take them away from your data sets. They might actually be telling you something. Either people who do not feel anything, there's something systematic about them, or you just have to get, so it is case specific, but most times we remove empty cases or null values when we are doing our data analysis. Another issue could also be wrong labeling or also duplicate columns or duplicate rows. Other issues could also be you having to filter based on some certain condition. So let's look at an example of, so this is a data that we created, not we created, where we adjusted to have some data issues or data cleaning intentionally. And we are going to be showing you like the data cleaning that you require for each of these. So if you look at, so let's treat the renaming rows or column. So we know that this is a column, this is a column, this is a column, this is a column. So one of these columns that probably might need renaming, which is the data cleaning, is look at this school. For example, this is called bachelor's partial college. So this should be like something like level of education, not school. So this is how you pay attention. So you need to just probably rename this, and maybe probably for purchase bike, you might add purchase underscore bike, or marital status, marital underscore status. If you're working with Excel, you might not have issues with something like this, but sometimes you might need to rename the column. So you might need to rename this column. Also, another thing when it comes to renaming rows. So if you notice that everything here, you have bachelor's, partial college, then we have bachelor's degree. Now, the way your programming language or the way your software or your Excel or Power BI sees this thing, it sees them as separately. So it sees bachelor's as a different thing. It sees bachelor's degree as a different thing. As a matter of fact, if you have bachelor and you have somebody else with bachelor's, it is two different things. So your programming is not as smart to figure out that, or text-based things they are the same or they look alike. So try to ensure the consistency. So if you find out that there's a particular role, remember this is a role, there's a particular role where the data is not consistent with the majority. So what you have to do is to clean them, like try to make them consistent with the others. So that this bachelor's degree, we need to rename them to be bachelors. And sometimes it might just be everything that has issues. For example, if you take this to a different like programming language, you will need to remove this dollar sign because um you also even need to remove this comma because some software will not read this as a number. So they won't read it as a numerical variable again because this already has a dollar sign. So they are not saying it as number again. So they are saying it as a string, or they are saying it as a text. So for you to conduct your analysis, you need to remove the dollar sign for everything. But it depends on how this was coded in Excel. There's a way this might still work. However, you probably don't remove things manually every time. So there are ways you can remove things in an automated way to clean your data. So this is just to try to tell you these are potential things to look out for. So first of all, if you have a numerical data that doesn't look exactly numerical, you can run your analysis to see if it's going to work. If it doesn't work, then you know that you need to remove the text or any text that is in that numerical data. Another thing also is if you find out that um there's a particular row that is not consistent with other rows, you need to make that row consistent with other rows. Also for empty and or null values, so this is where we have empty cases here. So for this row 10, 11, 12, 13, 14, we have empty for income. So you can decide to say, you know what, all of these 10, 12, 13, 14, we are going to remove everything in this line because they have empty for income. Um, some rows that have empty might not be as important as some rows that have empty. If you look at this particular data set, some of the variables here are more important than one another. The most important variable here, if you work with this data set, will be purchasing this bike. So because this is the variable that we care about, if somebody purchased a bike or not, then you can check purchasing a bike by income, purchasing a bike by education, purchasing a bike by region, or purchasing a bike by marital status. If we have empty in this bike purchase, because that is our focal variable, or that's our most important variable, then we probably would want to ensure that anywhere they say something is empty here, we would remove everything. So sometimes we might also care about, okay, even though it's not our focal variable, something like income, we can still try to say, let us remove everything. However, if you're not sure of should I remove or should I not remove, you can run your analysis for both conditions, that is keeping the empty spaces and without the empty spaces, and see if that is going to affect like your results, to see, okay, is the difference minimal, and that is like the decisions you make as data analysis. So we spoke about wrong labeling. So wrong labeling is if you are supposed to have education here and here you have school. Another thing is also if you have duplicate columns. So one thing you can notice about duplicate columns is, so for notice here we have gender and we also have gender here. So these are things that you need to look out for. So this doesn't make sense. So you probably would just want to take out one or drop one. So having duplicate columns. Another thing is also having duplicate rows. If you notice that you see for year from number 6 to 9 is the same thing as from number 14 to 17. This is 30,000, 10,000, 160,000. If you run this analysis, it's going to give you a result, but this is wrong because you have duplicate rows, which probably was imputed by human error, or probably this was by some person's mistake. Probably somebody was filling the data and they filled the data 3 times because they thought they had internet issues and things like that. So as a data analyst, so what you want to do is you want to remove duplicate rows. So remember that there are also ways you can do this in an automated way. So you just have to drop this 6 to 9. Also other things you can do is like filtering. So I can say, okay, for my analysis, probably majority here are earning about, let's say, 10 to $80,000 or $100,000. But there's this person here that earns like $160,000, which is a little bit like an outlier. So an outlier is a data that goes way beyond like the data distribution. I can say, okay, because if I include this $160,000, there's a way it might affect my analysis. One of the things you can do is to say, okay, where the income is greater than $100,000, let me take them out. Because so you make decision as you do your analysis. So they are like, sometimes the decision may be difficult. Sometimes you might not know if that's the right thing. That's why when you're writing your reports, you include the decisions that you make and why you made some of those decisions. So this is like a mini like issues that you might have when it comes to like, or not issues, or many issues that might happen with data analysis. So there are probably a lot of data cleaning techniques that you need to master as you work with more projects. You would get to see how well, this is how you need to clean your data more effectively. So dealing with outliers. So we remember, so outlier is one of the most common things that you need to figure out when it comes to data cleaning. So if more like the data that we showed you earlier, that was saying $160,000, and probably majority were earning $100,000. One thing that you can use to deal with outlier could be common sense. So common sense could be either I remove wherever I see 160,000, or wherever I see that the income is greater than 100,000, I take them away from my data, or anywhere I see that the income is greater than $100,000, I replace them with $99,000. So you can replace. So you can say, okay, anybody who earns above 100,000, let me just say they earn 99,000. But that is you also manipulating your data. You have to also be explicit about you doing that. So there might be the conditions why you want to do that. So there's something called data imputation. Those are like part of the things you could do, but data imputation is used more when you have missing data. So you could use for you to know if there's also an outlier because if your data is too large, you might not be able to know if there's an outlier in the data. You can look at the mean, the median, and the mode of the distribution. So you basically know outliers, or you figure out outliers for numerical data. So you can get an outlier for a text-based data. That is a categorical data. So it's only in numerical data that you can find an outlier for. So find what is the mean of that particular column, find what is the median, find what is the mode. Especially if the mean and the median are far wide, like from one another, like that if the median result is like 70 and the mean is like 1000, so then there must be something wrong with the distribution of the data. That means the data is either skewed to the right or to the left. So that's like one of the things. So the decision you can make there could be, okay, let us try to look at what are the potential issues. One mathematical formula people use is called interquartile range. So what they do is they look at the Q1 and the Q3. So in this video, we would not be talking about how to apply the interquartile range because that might be a little bit high level. When you work on projects, most times when you have outliers, you would mostly use like your common sense to figure out how you want to deal with them. So it's not all the time that you want to take out outliers. Sometimes you just want to drop them. So some outliers might not disturb your analysis result that much. Sometimes they might. So that is why you kind of look at, okay, what do I need to do in this particular scenario? Or if you are working with a colleague and they tell you, okay, let us try this. Or like I always say, do them in different conditions and see if the difference is going to be minimal or it's going to be large. So when it comes to data, and particularly for data cleaning, so there's something called reliability and validity. So reliability is how how reliable is your results? Like how is this result reliable? So, and that's something that you need to care about as a data expert. So you need to be thinking about this my result. Is this reliable? So there's something called internal and external validity. So external validity is if you have a sample, is this result going to be the same for everybody? That's for the whole population. So that's like for a customer base, right? Let's say you're an organization and you have 100,000 customer and you do like a survey for 1,000 customers. So external validity means that this 1,000 customer, they're representative of the 100,000 customers that we have. So that's the population for your organization. Internal validity is that is this result, is it even representative of the 100, is of the 1,000 customers that we surveyed or we sampled? So most times there might not be like a formula to figure out what internal external validity is, but as you do your analysis, always think about, is my result reliable? So have this like in your mind when you run your analysis. Um, that's all for today. So it's basically try to ensure you just familiarize more with this concept. It's short, but it's very important that you try to learn some of these, and these are like important data analysis tools that you would need to have even before you run your analysis. In subsequent videos, we're going to be speaking about what are the type of analysis you need to run for different type of variables that you have. If you enjoy our content, you can follow us on our social media page on LinkedIn, Twitter, and Instagram, or visit our website at www.velonti.com. Thank you.